So this topic is the last as far as our heavy strategies for integrating. And so we've been putting off kind of doing the easy ones. We've been putting off rules where we don't have everything that we want or we can't change the form. Well, now we can try to change the form. This is called substitution method. And so it comes from the fact that when you have something like a sine of 2x and you take the derivative of the sine of 2x, a chain rule problem, you would get 2 cosine 2x. And so if you were integrating, that's going to take you back to here. So we have to be able to change the form somehow to make this show up. We have to change it so we see what we want it to see. Okay, so there's some strategies, and I think the best way is just to show you some ideas. So if you look, things you can think about here, when you go to this integral here, it looks like a lot of stuff. But if you know the chain rule, derivative of the outside equals the or times the derivative of the inside, you get all that kind of stuff. So this is the inside, and I look at that and say that's x cubed. The derivative of that is 3x squared. So I'm going to pick something to substitute. I am going to substitute and let u equal x to the third. And you're going to see some different strategies for substitution. Please use them. You might not think you need them on an easy one like this. That will be helpful later on. So our step is to pick a u and then find the derivative of u. And here's the key. The derivative of u is 3x squared dx. Okay? So our substitution method is to find the u, take the derivative, and then we solve for dx. So dx equals du over 3x squared. Trust me, this ain't my first rodeo. You're going to wish you did learn this when we get to the harder substitution ones. Okay. So we are direct substituting. So I'm going to write over here where I have some space. So I didn't substitute anything in for 3x squared. I am substituting a u for x cubed. And then for dx, I'm putting in du over 3x squared. And so you'll notice what happens is the 3x squareds cancel out. So I just have the integral of the cosine of u. Well, the integral of cosine is easy. It's sine of u plus c. And then your last step is to substitute back in. So what we did is change it to a problem, not unlike when we did derivatives, they were chain rule. We change it to a problem that is something that's a little easier to solve. I don't have all that distraction. Now, this one you probably could have done without that help. Okay, they're going to get a little more complex. Okay, let's go to the next one. Strategy. We have a radical here. So a strategy for u substitution is to let quantities equal u. That is a quantity. Okay, and then see if we can substitute. So the quantity, x to the fourth plus 5. You rarely let the whole thing equal u. If you're going to do that, you wouldn't need substitution. Derivative, 4x to the third dx. The derivative of that's 0. Then I solve for dx. These are your steps. If you follow these steps, it's the same every time, and everything will work itself out. If you just follow intuition, you might get stuck when your intuition gets up against a little bit harder problem. Okay, so substitute. Nothing for x cubed. I can take out x to the fourth plus 5 and put in a u. So I'm going to write that as u to the 1/2, square root of u. And then dx is du over 4x to the third. Cancel out the x to the thirds. So I'm just taking the integral of 1/4. I move that out front. There's my 1/4. U to the 1/2. If you integrate u to the 1/2, that would be u to the 3/2 divided by 2/3, or divided by 3/2, which is the same as multiplying by 2/3. So this would be 1/6 u to the 3/2 plus c. So your last step is to plug your u back in. Take out what the u was and put it next to the 4 plus 5. Now, eventually you get good at this. You'll start skipping. You'll know where to skip steps. Don't skip steps now. You're never going to learn the actual technique, and then you're going to not know where to pick it up and leave it off. Okay, let's do another one. Next one on the list. These are the problems that we're going over in class in case you want to hear them again. Okay, again, I have a quantity here. So I'm always going to try to let a quantity be my u and see if that helps me with anything. Or I can look at this whole thing and say, is that going to help me find anything? So if I let u equal sine x plus cosine x, now du is cosine x minus sine x, all that times dx. Derivative, derivative. Solve for dx. Du cosine x minus sine x. So before I go on, I'm going to look over here and say, okay, I know I'm just taking that out and writing u squared. But when I take dx out and put this in, I now just reintroduced something back into the problem. And so you're like, I don't know if I really helped anything. So then you go back to other strategies. Maybe there's another strategy. It's a perseverance problem. Maybe it's not a strategy issue. You just have an issue with the perseverance. So let's look at it and say, well, I also know I can change the form of stuff. So I can multiply this thing out, change the form, sine squared and cosine squared. That's my outside and inside, or my first and last. Sine x cosine x. So that would be plus 2 sine cosine. Well, things that you know, sine squared plus cosine squared is 1. So just by doing a little algebra, we have 1 plus 2 sine x cosine x. Now we can think about substitution. And I'm going to split this up into two integrals. So the integral of 1 plus the integral of 2 sine x cosine x. The nice thing about sine and cosine is that our u could be either one because they're derivatives of each other. So I'm going to do the one that I think will make the right sign. So let's let u equal sine of x. So du is cosine x dx. So I solve for dx. Du over cosine. Now I go back to substitute. Well, I know the integral of this is x. The integral here, now before I do this, I need to substitute. So I'm taking out sine and putting in u. So I have integral, or 2 times integral of u cosine x times du over cosine x. So basically I end up with the integral of u, which is u squared over 2. That's going to cancel out. If this 2 came back in here, it's really the integral of 2u. Well, that's an easy integral. That's u squared. And then the last step would be to put sine x in there. So we have x plus sine x squared plus c. So sometimes perseverance is more important than getting all the steps right. Trying different things.